Hello friends, we will see now the angle between two straight lines in 3D geometry. We have earlier seen that angle which is given between two lines is as cos theta is equal to a1a2 plus b1 b2 plus c1 c2 divided by under root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. So we have derived two things, that if two lines are parallel then their direction ratios are proportional. So condition of parallelism was a1 by a2 is equal to b1 by b2 is equal to c1 by c2, where a1, b1, c1 are dr of first line and a2, b2, c2 the dr of second line. If two lines were perpendicular, we have seen a1 into a2 plus b1 into b2 plus c1 into c2 is equal to 0. We will make use of these two properties to find different questions. See, in the first question, find the vector equation of line passing through the point this and perpendicular to two lines. What we need for finding the equation of a straight line? We need one point and its dr, direction ratio. One point is luckily given for the required line, but dr is not given. Let us take the drs as a, b and c. So the dr of the required line is a, b, c. Now the required line is perpendicular to this, so we will apply this relation. It will come out to be a1 into a2, that means 3 into a plus minus 16 into b plus 7 into c is equal to 0. Condition of perpendicularism I have applied here. And the second line is here, and the required line is also perpendicular to the second line. So it will be 3a plus 8b minus 5c is equal to 0. So if somehow we are getting the value of a, b and c, we will get the equation of the line. See, how to solve two equations having three variables. That condition we encounter in so many cases. I am just telling you the cross multiplication method. You write a, b, c like this. Just put equal to. When you are writing a, you have to cancel this and take care of the coefficients of b and c. What is that? Minus 16 into minus 5 minus, that means this into this minus this into this. That is what? 7 into 8 is 56. And for b, what you have to do? You have to just ignore b things and write the other things. After b, it is c. So start from here, not from here. So 7 into 3, 21 minus 3 into minus 5. That is minus 15. And for c, you just ignore this, and after c it is coming a, so take care of the quotient of a first. So this is 24 minus 8 into 3 is 24 minus 48. So it is coming out to be a divided by 16 5s are 80 minus 56 is coming out to be 24. B by 21 plus 15 is coming out to be 36, and C by this is coming out to be 72. 24 plus 48. So taking the simpler ratio, we can write a by 1, a by 2. If we divide just by 12, everything is equal to b by 3 is equal to c by 6. Is it? So A, B, C we can easily get. What is A? A is 2 lambda, B is 3 lambda and C is 6 lambda. We got the value of A, B and C. Don't be afraid of the symbol lambda here. That is the constant and that will cancel out because equal to is there. So the equation is passing through one point and having the drs. This is taken as x minus x1. What is that? 1 by A, that is 2 lambda, is equal to y minus y1, y minus 2 by, this is 3 lambda, is equal to z minus z1, z plus 4 by 6 lambda. Now you cancel out lambda and this is the required Cartesian equation of the straight line. Now if you need to find the vector equation of the line, what that will be? You just see here, we can write vector r is equal to A passing through the point, that is 1i plus 2j minus 4k plus lambda times to which it is parallel, 2i plus 3j plus 6k, 2i plus 3j plus 6k. So this is the vector equation of the required line and this is the Cartesian equation of the required line. So very important concept we have used here, that two lines to be perpendicular, a1 a2 plus b1 b2 plus c1 c2 0. We just made use of that property and got the unknown thing and got the equation. Now jump to question number 2. Find the image of point this with respect to the given line. You just draw the diagram. The line is here, point is 1, 6, 3. So for finding the image, see here, we need to find this point where the point and the image joining is meeting the given line. If we are getting this point, we got this point, we can get this point very easily. Now we see that how to take a point on a given line. The line is x by 1 is equal to y minus 1 by 2 is equal to z minus 2 by 3. Let us take r. So any point on the line can be taken in the terms of r, as x is coming out to be r, y is coming out to be 2r plus 1 and z is coming out to be 3r plus 2. Let this be the point. If I just write this a, b, c, d and e. So let us take the coordinate of point E as r comma 2r plus 1 comma 3r plus 2. Now you see that CE is perpendicular to AB. So we will get the dr of CE. dr, direction ratio of CE, is given as, we know that it is x2 minus x1. So this will be r minus 1 comma 2r plus 1 minus 6 comma 3r plus 2 minus 3. So it is coming out to be r minus 1, 2r minus 5 and 3r minus 1. This is the dr of CE. Now AB is perpendicular to CE and we know the dr of AB is 1, 2, 3. And we will apply the condition of perpendicularism, that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So 1 into r minus 1 plus 2 into 2r minus 5 plus 3 into 3r minus 1 is equal to 0, because this line is perpendicular to this line. We'll get the value of r from here. This is r minus 1 plus 4r minus 10 plus 9r minus 3 is equal to 0. So this is coming out to be 5r plus 9r, that is 14r. This is minus 1, minus 11, minus 14. So coming out to be 14. So r is 1. Once we got the value of r, we will get this point easily. Once we are getting E, so what is the coordinate of point E will be? On putting r is equal to 1, this is 1, comma, this is 3, comma, 5. So, E, coordinate of E is coming out to be 1, comma 3, comma 5. Now we have to find the image. Let it be alpha, comma beta, comma gamma. Then you know that the midpoint of CD is E. So what it will be? Alpha plus 1 by 2 is equal to 1. Beta plus 6 by 2 is equal to 3. And gamma plus 3 by 2 is equal to 5. We will get alpha, beta and gamma from here, which is the image of point C with respect to the given line. Hope you are understanding. Thank you.
For useful videos, subscribe to my channel Santosh Pembi on YouTube or log on to my website www.mathsonphone.com. Thank you.